This
what is Git,
conference will now be recorded.
why do we need Git, okay, everything about Git from basics till advanced topic, and then we'll integrate it in the pipeline, like where Git comes into, what is its purpose, all of them we'll be talking about here, right? So yeah, let's get started with Git. And yeah, Git is a version control system. First of all, we'll see what is a version control system. Like I said, I'm assuming everyone is new. From basics till advanced concepts will go. Okay, we'll start with version control system. We'll learn why we need this version control system, what are the benefits, what are the uses, what are the different use cases, and then we'll get into Git concepts, Git architecture, and then branching, rebase, reset, merge without conflicts, merge with a conflicts, and pull with a rebase. All of them will be dealt with. So let's get started with Git. See, once we learn Git, okay, we shall talk about how it works in the pipeline, and then we shall start learning Jenkins. Once we learn, then we'll just come and start with this pipeline. Means we'll just create this pipeline step by step by integrating the tools. Okay. So yeah, this pipeline creation may take a month or more. Will we just learn the tool, come back and implement it in the pipeline? That's a agenda of the course. So yeah, let's get started with Git. You might be using a different version control systems, or else maybe you might be using it. Yeah, but still let's go through every concept of it. Yeah. So let's begin with the version control system. What are version control systems and why do we need it? What is the purpose? Anyone using any version control systems, anything is fine. See, there are so many version control systems like Git, you have SVN, TFS, Perforce, and so on. So many are there. They have different architecture. The way they work is different. Right here in this course, we are learning it. Why Git? What are the differences? We'll discuss. Before that, let's begin with version control system. What is this version control system? Why do we need it? Who uses it? Any inputs from your end?
Is it the version of the code?
Yeah, it can help us maintain the versions of the code. Like anyone in IT should learn. What I mean by this is like you might be a developer or you might be a tester, you might be an ops person. To manage your project better, you might be having some program files, script files, or configuration files. To maintain versions of any of these files, you can use this version control systems. Earlier, it was only developers who write the code, right? Like they were not many other teams were writing the code or writing the scripts. So it was basically a developer tool. It's a mandatory for them. But now everyone else in IT uses it. A DevOps person uses it because let's say we are a DevOps team. Yeah, we do write the configuration files like with the Terraform, with Ansible the configuration files, Kubernetes files, and so on. All of them should be version controlled. So we need this version control system like Git to manage our projects. Similarly, even testers use them. They have a lot of test scripts. They might be using some automation testing tools like Selenium, UFT. Even they have test scripts. All of them can be version controlled. So everyone in IT should learn this tool. And also first we learn this tool with respect to managing our project. Then we'll also learn it with respect to implementing it in the pipeline. So first let's talk about what is meant by version control. Here to understand this, let me take a simple example. I'm taking up a scenario without version control system. Okay, imagine we don't have a version control system. So there is a team and they have all their project, all their program files or all their files kept on some remote location. Okay, they were all kept on some remote location. Let's say here they have file one. They could be any program files, Python scripts or shell scripts or else C programs or a .NET, whatever, or else they are simple text files. Any files can be version controlled. So imagine it's some Python file. Okay, so it was kept on remote and every team member can be sharing the files from this remote location. There is a developer A, developer B. Suppose both want to work on the same file at the same time. So they got this file to their local computer at the same time. Okay, both of them downloaded it to their local computer. So now A made some changes to this file. Okay, and let's say on day one, A kept the file back. He made some modifications and then kept it on remote to share it with others. Similarly, B also have got the file at the same time like A, and after 2 days, maybe on day two, B kept the file back, right? So after 2 days, this file one will have which person changes? Without version control system, if you don't use version control system, finally after day two, this file one will have which person changes? Will it have both the person changes without using version control system?
It'll be day 2, right? The person who
Only,
last checked in.
yes, who made the changes last? Simple logic, right? Because we are not maintaining versions. Obviously, what happened? Only person B changes will be there. Means what is happening here? B is overwriting the changes of A. Correct? If this keep on continuing, if this keep on going with, let's say a team may have 10 members or whatever. So if this keep on going at some point of time, right, the project may be corrupted or messed up, right? So one person is overriding changes of other, B doesn't know he's doing it, even A doesn't know his changes are gone or lost. See, each of them will be working on their requirements, they'll be working on their code changes and all. They cannot just sit and check whether someone is overwriting their changes or he is overwriting other changes and so on, right? So there comes a need of a tool which should take care of this. Means the tool should allow people working simultaneously. Means a person, means multiple people can work on the same file at the same time, right? How is that possible? We cannot just take care of it manually. That's where again version control system comes in, allows people to work simultaneously. Even though both of them working on the same file, it can help us. It will not allow overwriting or it will not allow ignoring the changes. Rather, it will inform us, okay, both of them are working on the same file, you should do something here, like which person changes to give, it should inform us, right? So such a tool is a version control system, allows developers or any team to work parallelly, to work more collaboratively, right? So that's where version control system comes in. Not only that, if something goes wrong, let's say application is working fine till 7 a.m. Okay, 7:30 something happened, something went wrong, application crashed. You want to see what happened in between. So you need a very detailed logging kind of like 7:15 a.m. person A made changes to file 1.py on line number 6, right? So this kind of detailed logging, including the timestamp and including the changes what he made. If you have this kind of detailed logging, okay, you can undo these changes so that the system would be back. Whatever problem the system is facing, whether it is down or any service failed, you can just revert it, right? So a detailed logging is important, which we cannot again do manually. When you have a huge team, multiple people are working, you need such a kind of detailed logging, history of the changes we are making, right? Including the file name, including the line number, the person who made the changes. So again, version control system comes in picture here. Also, maintain the backups, maintain the versions. Don't ever delete the versions. Let's suppose you're working on a file. Let's take the same file, this program, it's a version 1. Client want to modify this and with some modifications make a version 2. Suppose you just edited the same file and made version 2. You don't have version 1 anymore. But after a few days, if the new version, new changes are not working, they may want to go back to the previous version, right? So if they go back to the previous version, means like how can we go back because it is deleted? Again, he has to develop it, right? Again, we need to develop it. A lot of rework. So don't ever do it. Don't delete the older versions. Don't edit the versions and make new versions. Always maintain backups, maintain versions, which you can achieve through version control systems. Hope you all got an understanding of what a version control system is. Version control system helps you maintain your projects, maintain the version of your projects, right? These projects could be any program files, any scripts, any configuration files. Means everyone can use this for proper collaboration in the team and to have a proper work environment, right? So this is what version control system does, and there are many other version control systems. And depending on their architecture, they were categorized actually. If you see here, based on the architecture, version control systems were categorized as centralized and distributed version control systems. If you see the centralized version control system, you have a central server or a remote repository here. Okay, this is a central server or a remote repository. All the project work, all the code base is kept here, and this is the workstation of each developer. Okay, they'll connect to this remote server, get the code, make changes, and put the changes back. This is how they work. And this is a central version control system. And there are few drawbacks with this kind of architecture. The first one is always you need to have network connection to work on, right? You need to connect to this remote server, get the changes, and then that's how you work. Suppose if network connection, there's some network problem, network disconnect, entire work will be halted. I'm sorry. So entire work will be halted, right? So that's one problem. Another thing is it is like a single source of truth. All the project work, all the code base is kept here. For any reason, if the central server is lost or crashed, right, entire work is gone. Right? This is another drawback with this kind of architecture. So to overcome this kind of these problems with the centralized version control systems, we have distributed version control systems. Let me talk about the distributed. See here in the distributed architecture, you will have two repositories. This is a central repository or the remote repository, whatever you call it. And this is the local repository. And here, this is the workstation of each individual developer or collaborator. Here you can see this is the workstation of each individual developer. Okay, so let's say there's a developer's workstation, developer one. So he's having also local repository, means every user or every one will have a copy of this remote into their local computer, right? Which is called local repository. And this is a remote repository, right? And again, developers will not directly work here, rather will be working on a working copy, or else it's called as a working directory. Make changes here, then move those changes to local, from local to move them to remote repository or central repository. It's like a 3 steps before your changes goes to remote, right? And majority of the time we work on this local repositories. Once complete work is done, we'll push to remote. Right? Until you push your changes to remote, they are confined only for yourself. Right? Only once we move our changes to remote, others can see the changes. Okay? And here, this kind of architecture overcomes the drawbacks of centralized version control system. How? Let's see. See, suppose there are no network connection, network disconnected. You can still continue working on local. Right? Once network connection, once network resume, you can push to remote. Only push and pull, you need to have a network connectivity, right? And push and pull means you are copying from remote or else you are moving your changes to remote. Yep. So these push and pull are less frequent when compared with the actual changes you're making here. Only you pull once you're, you want to get a copy, you pull, or else once your changes are done, you push, right? So these commands are used less frequently. Most of the times we work on a local repository. So network connection is not required all the time. And another thing is, because we are working on local repository, which is on our own computer, it can be working like it is a bit faster than centralized version control system, because this local repository you're working means it's just accessing your hard disk, right? So this is how it eliminates the drawbacks posed by centralized version control systems. Even though network connection is not there, you can still work on your local. And also, yeah, see here, if this central server or remote repository is lost, chances of recovery are more, because see, every user is having a copy of this remote repository. So yeah, we can retrieve the changes from that. Chances of recovery are also more. So this is a distributed version control system, and this is the kind of architecture we are using nowadays in the modern DevOps projects. Particularly, our Git falls under this distributed version control system. It's a distributed architecture. And what are these centralized version control systems? SVN, TFS, Perforce comes under centralized version control systems. Git, Mercurial, Fossils comes under this distributed architecture. Clear with the architecture, everyone? Any questions in this part?
I have one question, Preeti,
Yes, please.
with the distributed. So, the distributed, there is one version, and now 3 developers are pulling the same version and they're making changes on their local, right? Now, once
Yes.
they make the changes on their local, when they're pushing, so if now developer 1, 2, and 3 are pushing at the same time or whatever, right? So then what changes? How does the version get updated?
See, if every person is moving the changes to remote, whenever they are moving the changes to remote, whenever there is a conflict, let's suppose they have pushed the changes simultaneously. Okay, let's say the same file, let's talk about the single file. So whenever they are moving their changes, if the file is having multiple people changes. So here what happens, Git does not know actually which changes to give. It's after all a tool, right? But it will not override, or else it will not ignore any person changes. What it will do, rather it will inform us. Okay, yeah, developer A changes are there, developer B changes are there, which changes to keep. It will inform us. So that's called a conflict. We are going to discuss all those scenarios with a hands-on. Okay, we get a conflict. So how to resolve this conflict? What are the steps to be taken here? All of them will discuss.
Okay,
Okay.
I'll wait. Okay, thank you.
So once we step into the lab, we'll be talking about different scenarios, how Git handles the conflicts, how multiple people can work on it, what are the steps we need to do, all of them we shall discuss. So, but remember one thing, yes, Git will not allow overwriting or like unlike you just don't use version control system, so it will not allow overwriting. It will not allow ignoring the changes also. It should not ignore any changes, right? It should keep everything. So it will not do either of them when there is a conflict. It will inform us. As a person who made the changes, actually what happens is, I'll just give you an overview. Suppose there is a file 1.py. Okay, developer A, developer B, both are trying to make the changes, or else let's say they made changes in their local computer, in their local repository. Now they are trying to push to remote. So now it will inform both of them. There were conflicts. There is another conflict from developer B. So similarly, A will be informed that there is a conflict from developer B. B will be informed that there is a conflict from developer A. So they will sit together, developers sit together, A and B should discuss which changes to keep, which changes to eliminate. They'll fix the result, they'll fix the conflict. How to do that? We'll do it with the hands-on on the lab. So yeah, this is the architecture of distributed. And yeah, you can see the graph. This is the graph from Google Trend Reports. You can also check with the latest graph. It is very widely used when compared with any other tools. The reason is it has a great feature, particularly the branching feature in Git is very robust and very much helpful in the modern DevOps projects, right? So Git is very widely used and when compared with any other tools. So yeah, if you learn Git, if you master Git, it helps you a lot because almost every project is using Git now. Yeah, now we discussed about the architecture of version control system in general, right? Now let's talk about the architecture of Git in particular. So yeah, you can see here, this is a local repository and this is a remote. Like we discussed, there are two repositories. Yeah. Now, if you see here, this is a local. This is remote repository. Remote repository means yes, it's already. Let's imagine I'm a new team member to DevOps project. I joined the team today. So now I want to make some changes. Already project is running. Okay, it's let's say it's a 2-year-old project. So I can just copy from this remote and create a local repository in my computer. Okay, then how do I make changes? I don't make changes directly here. Rather, I'll be making a changes on this working directory. Means let's say it's another directory or another folder. If you are a Windows person, it's a folder. So I'll make changes here. And again, after making changes, I cannot just push my changes this way. I cannot from here, I cannot just push my changes this way. Rather, what I'll do, from working directory, I'll move my changes. I should move my changes to staging area. Give me a second. This is the local repository. Okay, from working directory, I have to move my changes to staging area. From staging area only to local repos, I cannot just do this way. This is not possible. Okay, means it's like a 3 steps before you go, before your changes goes to remote. And what is the staging area, by the way? Why do we need it? See, it is a kind of, this staging area is also called as index area. Okay, it's a kind of preview or else pre-check before your changes goes to local. It's actually a virtual layer. Okay, it's a virtual layer. Once you make your changes here, you push your changes to staging area. From staging area, you move them to local. This is how Git works. Like I said, it's a called an index area or it's like preview, pre-check kind of. It's a virtual layer. How is that actually doing? Let me tell you. Suppose there are 10 files here in your working directory. You want only 5 files to be placed in local, then those files to be pushed to remote. So when you have 10 files, you add only those 5 files here, whichever you want to have to local. You don't add all the 10. Only place 5 files in staging, and whenever you do a commit, there are so many commands. We'll learn the commands with on the lab. So just understand whenever you make a commit, whatever in the staging area is going to be committed to local repository. Means whatever in the staging area will be moved to local. So it helps you like a kind of pre-check or a preview or like a before your changes goes to local. Okay, or else directly from here 10 are there, 5 I have to push directly. I don't have any preview or else pre-check kind of. No. Okay, so first you move your changes to staging, then to local repository. Okay, this is how your changes, this is how you move your changes in the repository. Okay, this is the one you need to take care of. Got it, all of you? So finally, how do your changes goes to remote? First, from working directory to staging area, from staging area to local, from local to remote. Okay, once you feel like, okay, these changes are fine, you can move to remote. Once you move your changes remote, others can see the changes. Right? Got it, everyone? Any questions here? See here, let me tell you another very interesting step here, another interesting part. This local repository, working directory, you can consider like some folders. But the very important thing or the point you need to consider here is, this is physically the same directory. Physically the same, only one directory, one folder. Then how can you say local and working? Logically, they are different. I'll tell you how it is. Imagine this is a folder, okay, or a directory, and this is your working directory. The same is your local repository. How come the same is working directory and local repository? Suppose if you just created a file, then this file is set to be in working directory. Okay, then you run the command git add on that file, git add that file name. Then it is set to be in the staging area. It is say if you see it is in the same box, it's in the same folder. Then if you do git commit, then it is set to be in the local repository. Means what is your local repository? The same folder. What is your local, what is your working directory? The same one. Both are same physically. Logically, this is how you refer to the files and folders. Am I clear? Yeah. A simple logic. It's the same folder. If you just make the file, if you just created a file, if you are just working on it, means it's set to be in working directory. If you run a command called git add and the file name, then yes, it is moved to staging. Then when you run commit, whatever in the staging area will be moved to local. Then you say, yes, my changes are in local. Got the point, everyone?
So in your previous example, when you were explaining that you have 10 files in your working directory and you want to move only 5 files to the remote, then you're committing those 5 files to the local repository, and then only they'll be moved to. So whichever files you're committing can be moved to remote.
Yes, correct. Whatever in local repository will only be moved to remote.
So the
Okay.
command should be run, the commit command should be run on those files, then only they can be moved to remote. And we will run the commit only on the files that we want to move.
Yes, actually,
Okay.
see here, I have 10 files created. Okay. I want to place only 5 files. Only 5 files I'll add to staging. Then whenever I commit, whatever in the staging area will be committed. I need not commit each and individual file. When I run commit command, whatever in the staging area will be committed. Of course, if you want, you can also commit each file separately. But generally, we just run commit, means whatever in the staging area will be committed. So these 10 files are in directory, 5 files are in staging area because I added those files. Then commit means these files will be in local. Then when I push, only these files goes to remote.
Got it. So staging is add and commit is local to remote,
Yes,
right? Okay.
correct. After commit, when you push, they go to remote.
Got it. Thank you.
So this is how it works. And you remember all this. See, I'm going to show you all of them practically with a hands-on. Okay, this is just giving you an idea, an overview, and theoretical part. Once we step in, I'll show you everything, whatever I'm talking here. Okay, you will have a clear visibility there. And one more thing you need to understand. Local repository. How to create this local repository? Two use cases can be there. One is, let's say it's a new project. Okay, it's a completely new project. Now team is formed. We are DevOps team. Now only team is formed from the scratch. I need to develop some configuration. There is nothing on remote. So how do you create local? I'll create local repository manually. First, I'll create an empty local repository, then create the files there, commit them, then push to remote. Means local repository can be created manually without copying from remote also. Of course, an empty one. Later on, develop the code base and push to remote. That's one thing. Another way is, like I said, copy. Already project is existing. I joined the team as a new member. Copy from remote and create it. Basically, local repositories can be created. LR means local repository. How do you create local repository? Different use cases. You can create an empty one manually, then later on push to remote. Or else copy from remote and create a local. Right? You can do it in multiple ways. First, we'll start with this scenario. Means assume it's a new team, it's a new project. So I'll just create a local repository manually, develop it, then push to remote. Okay, then we'll also take up this scenario. If this is clear, we shall go to the lab. Shall we start the lab? We shall install Git, we shall start hands-on with it. Clear with the architecture, everyone? Understood this, everyone? And yeah, see now if you talk about this Git works on multiple operating system. It works on Windows, it works with the Linux, it works with the Mac and so on. Okay, we shall start first Git on Windows. Okay, see if you learn Git on any operating system, it's the same with any other operating commands are same, only installation will be different. So we shall be starting Git with the Windows. Later on, we shall also use it in Linux. Okay. So let's get started now. Let's install Git. Just for any Git, see you may be installing Git on Linux or Mac, whatever it is, you just do it from here. Okay, it's gitscm.com official website for Git. Okay, here you can say download, whether it is Mac or a Windows or a Linux, you can use it from here. Okay, I'm doing it now on Windows, so just go here. You can download this exe. Okay, depending on the bits of your operating system, just click on the download. Once it is downloaded, you can just run that exe. That's all. It is as simple as that. Okay, I have already done that. I'm not doing again. It's just download and run the exe. This link, everything is in the drive. Okay, I'll share you the drive link. You can just access the, I mean, you can get the documents from there. So just download from there. Okay, I mean, download by using the document. And here, once Git is installed, you can just go to your start menu and launch something called Git Bash. So whenever you install Git, you get this Git Bash. Okay, see, I'm repeating again, just download the exe, run the exe. I think it's pretty simple. You'll be going through a wizard, like it will ask you to click on next. That's all. In few steps, you'll get this installed. And this is the Git bash, which provides some shell environment to run your Git commands. Okay, so this is the one you can use. And here, before stepping into Git, let me tell you, as we go by for DevOps, we'll be using Linux environment. I think yesterday I mentioned this. So to get familiarized with the Linux environment, better use command line in Windows also. Okay, rather than using the GUI, try to use CLI from Windows so that you get used to the environment. We'll be doing rest of the topics like from Jenkins on everything on Linux. So before going to Jenkins, anyway, I'll teach you the Linux basics and all, whatever we need. So here also, rather than using GUI, let's use it from CLI. I believe you know how to use the CLI in Windows, right? Anyone new here?
Me. Yes, ma'am, me.
Okay. Okay, let me just give you a simple example. See, in Windows, if you want to go to any folder, you just double click, go there. If you want to create a file, you right click and create a file this way, right? You may create a folder or any file this way, right? Through the GUI, like through the graphical user interface operations, you just do it, right? Maybe you may drag and move it to whatever, wherever you want and all. So the same thing can be done from the command line of your Windows. See, suppose I want to go to this folder. Let's say I just want to go to desktop. Copy this address. And how do you go there? CD and the path. CD means change directory. Okay, you need to a little practice. That's all. It's not very difficult. CD means change directory. This is for any Windows persons. Okay. Here you see the path. If you want to make sure where are you? PWD, present working directory. I'm in the desktop. Okay, these are the simple things. Suppose now if you want to create a file or a folder, how do you do on desktop? You may just go to your desktop, right click, you create a folder, right? Create folder. But how do you do that from the CLI? See, using CLI is very effective in real time. In Linux systems, this is how we do. When you're managing huge files and folders, when you have to do the operations quickly and effectively, this is the best method. So how do you create a directory? Small command, mkdir. These are Linux commands. I'll teach you these commands separately. But if you already know Linux, just try this way. Or else if you are Windows person, do it through GUI only. Okay, no providers. I'm going to create a folder called demo for Git. Something like, let's say, Git example. Okay, I'm creating a folder. Enter. See, I'm also showing you what is happening at the back end. Let me do this way so that you get familiarized with this environment. See, whenever I do mkdir means make directory. Yeah. Here you can see a directory by name git example should be created. Yes. Do you see that? Okay. So how to go into that directory? cd git example. Okay, so just open it. Okay, this is it. So, okay, fine. Let's come to our Git. Okay, I have created a directory. Let's say this is the directory I want to place my program files, or else this is the folder where I want to keep my project files. Okay, meaning basically I want to version control this directory with Git. So go to that directory and like it's an empty directory, right? I'm not copying from remote. Let's say it's a new project. So I want to make this directory as a local repository. Whichever is a local repository, that directory will be version controlled by Git. So I want Git to version control all the files in this directory, and I want this Git example as a local repository. So go to the directory and run a command called git init. Git init means initialize git, start git. Okay, so that git could be tracking this folder. So git init. See, initialize empty git repository. So if you see here, whenever it is like you initialize git, a .git folder at the backend also, see whoever is new to command line, see the things at the backend here. .git folder is created. Means whichever folder is having .git means that is nothing but your local repository. That is nothing but your working directory, right? So here git example is having .git, so this is the local repository. The same is the working directory. Like I said, logically they are different, physically it's the same. So yes, I have created a local repository manually. Got it, all of you? I told you, right? Just two use cases. One is assume it's a new project, so create a local repository this way, an empty local repository. Okay, so yes, there's an empty local repository .git. Now, okay, fine, I want to have some files here, okay, and so that Git can version control. You may create any files of your choice. If you are a programmer, create files of your any programming language you like, or else if you want to have some files. See, here our interest is not to learn programming and all, our interest is to version control the file. So any text file will also do. I'm just creating a text file. Let's suppose I want to create a file. How do you create from the command line? There are multiple ways. I'm showing the basic way. Touch. Touch means touch file1.e. That file will be created. Like you go here, if you are a Windows person, create this way. New file. Okay. So touch. So at the back end, see here, file1 is created. Now I want to add some content. You can double click open and write the content. It's perfectly fine. I'll do from the CLI. Maybe I want to put some content. Echo is like a print command. It will print this. That output is redirected to file1. Okay, so now file1 will have some content. If you want to check the content, cat will read the content of the file. Or else you check this way. Don't worry about the CLI now. You do it with the GUI if you are new. Anything is perfectly fine. Here we are learning Git, not the Linux commands. So, okay, file is created. So, is this file being version controlled by Git? Yes or no? Is it version controlled by Git? Let's see. We don't know. So, let's see. Git status. See, it tells you Git know there is a file, file1, but it is not tracked by Git. It is untracked. Okay, it's not getting tracked. Why? It is giving you a clue. Add the file. See, use git add to track. See, always these are the very basics which one should be very clear with. I notice people like in the teams, people start working with Git without knowing this underlying concepts. So it will be just always vague if you don't understand what is happening in the backend. So make sure to be very clear with this basic architecture. See, always refer this with the architectural diagram like we have learned this one. See, it is saying untracked. It is asking us to add. See here, it is asking us to add. So asking us to add means where is the file actually? Relate to the architectural diagram and tell me where is this file. Physically, it's in the same Git example, but I'm asking logically, do you say it's in the working directory or is it in the staging area? It is asking us to add. Means what does it mean?
Move to staging.
It is asking us to add, means, yeah, we have to move to staging, means the file is currently in the working directory, isn't it? It's in the working directory. So that's why it is asking us to add, means it is here. Now, how do you add it? Git add file name. Sorry. Yeah. Now, again, check the status. Status command will help you understand what is happening. See, changes to be committed, right? It is saying changes to be committed. Means where is the file now? Can you tell me where is the file? Changes to be committed. To be committed
It's
means
in
where is
staging. It's
it
in
is in
staging.
the staging area. That's all. So now how do you commit? Git commit minus m. M means message. Whenever you make a commit, some message is mandatory, like a kind of comment. You could put a reasonable message here. Okay, this is related to module 2 or else functional requirement 4 or whatever. Okay, so I'm just giving something like first commit or first file. Now it says, yes, it is all committed. And when you see the status now, it is clean, means whatever in the working directory were added to local repository, right? Making sense, everyone? See here, physically also, you can see the file is in the same folder. Logically, it's different. Okay, let me repeat it with another file so that it should be more clear for all of you. Okay, before that, ls will show the files in the working directory. Git ls files will show the files in the local repository. Okay, now let me repeat it with another file so that it should be very much clear for you. I just created another file. See at the back end what is happening. I would like to put something like you open the file and put the lens. Okay, so done. Now check the status. Untracked because it's a new file. Now tell me, where is this file to? Is it in the working directory, staging area, or local repository?
Working directory.
Obviously, it's in the working directory. ls. See, both of them are in the working directory. Git ls files. Only file 1 because file 2 is not in the local repository. Hope you got the difference now. Now I'll add the file. Git add file 2. Now tell me, where is the file? I have added it.
Staging.
Yes, added it means it is in the staging area. Okay, now it says to commit. Okay, fine, I'll commit. Git commit minus m. Let's say second file created. So now it's set to be in the local repository. When you do git status, also when you do git ls files, both of them are in the local repository. See, here the file is always in the same directory physically. Logically, that's how we refer. Clear, everyone? With this architecture, always remember this. You should keep this in your mind when you're working. Okay, this is the architecture from working directory to staging, from staging to local, local to remote. We didn't go to remote yet. Remote, before going to remote, we have to do lot many things here. Then we shall go to remote. Until then, we'll be working on local. Okay. And here, one more thing. Whenever you are making a commit, for every commit, a commit ID will be generated, which is a hash code. Okay, that commit ID will be unique. If you want to see those commit IDs and the history of commits happened, there might be so many commits we might be making, right? Git log. See, 2 commits I made. See, every commit is having the huge commit ID like this. Okay, including, see the person, because I didn't put any username and all, it's showing the like this, including the timestamp and the commit message. This is what is a logging important, right? What happened to which file at what time. Yeah, the detailed log. If you just want to see simple brief log, git log one line. Okay, it will show you just one single line, and you don't need the entire commit. Only first 6-7 characters are enough to refer the commit. See here, first 7 characters of each commit and the commit message. If you just want to see the brief log, what is this head, what is master, we'll discuss as we go by one. Okay, so this is about the log. This is how you check the logs. Clear, all of you? Shall we take up another simple scenario? See, till now we were creating a file, that's all, right? We are creating a new file. Shall we also see modify an existing file and how it works? Yeah, let's see. Suppose I want to modify this file, file 1. Okay, so see, I'm using Vim editor. Don't get confused. I'll teach you this Vim editor later. So what you should do now, if you are new to Vim editor, you open the file like this and edit it. Just normally edit it. If you don't know Vim editor I'll teach you once we go with the Linux. You can also edit this. Let me edit here without Vim. Hello. Some dummy lines I'm adding. If you are into programming, you may write some programming files, whatever. Okay. Now I made some change to the file. Check the status. Haven't I saved it? 1 minute. Oh, file 2. Changes are not reflected here. Let me edit here. You can edit there also. Just let me edit. Let's say, let's save it. Now just check git status. Okay, it's not saved actually. Make sure to save it. So it says that, see, I have modified the file. Okay, and it says changes not staged. What you should do now? Yeah, like whenever you create a file, you add and commit. Same is the case here, whether it's a new file or whether it is a modification. See, it's a modification, right? Second line modified. So add and commit. Again, you have to add and commit. So what you should do again? You should do git add file1 and also do git commit. You have to do this separately, or else you have to do this one by one, like add and commit. Or else you can also do this way. Git add file name and instead of doing separately, you can also do this way. Git commit -a, okay, and -m means add and commit. You can also do this, but this you can do only for not new files. It's not a new file, right? But if it is a new file, you have to do it only separately. This is for new files, you have to do only this way. But file1 is not a new file, so you can do either ways. Got it? You can add and commit separately, or else commit with a -a flag if it is not a new file. But if it is a new file, you have to add and commit separately only. Okay, so let me try with the git commit -a -m file modification. See, you can also see the difference. If it is a new file, it will tell you like untracked file. But it is not untracked, it is unstaged. Changes are not staged, that's all. So this terminology is important. You have to understand the difference between untracked file, untracked and unstaged. Got the difference? If it is a new file, it will be shown like an untracked. But it is not a new file, only changes are there, modifications are there in the working directory, then it will be unstaged. For unstaged, I can run git add, git commit separately, or else I can also do with a single command for unstaged changes this way. But if it's an untracked, I have to do only separately, git add and git commit. Got the difference, everyone? Understand this terminology between untracked and unstaged. In our case, it is unstaged, not untracked, because it's not a new file. Am I clear? Please confirm me, everyone. Is this clear for all of you?
Yep, I'm good.
So now commit the changes. Okay, done. Now if you check the status, it tells you everything is good because I have added and committed. That's how you modify the existing file. See, Git always works with respect to changes. It could be a new file or it could be a modification. The concept is same. First, your changes whenever you make a new file, or else whenever you modify, you are doing a modification. It will be first in the working directory. then you move to staging area, then to local. From local, you move to remote repository. It could be the change. Like I said, Git works with respect to changes. Your change could be, like I said, creating a new file or modifying it, or it could be deletion also. Deleting also works the same way. Deleting we shall see in the next day. Okay, so whether you delete or whether you create or modify, first of all, changes will be there in working directory. You have to add them and then you have to comment. Then only you can move to remote, right? So if it is untracked, means if it's a new file, you have to add and commit separately. If it is only on stage, you can add and commit this way. These are the commands we have used till now. It's a git init, creating a directory. Okay, some small Linux commands like cd, mkdir. Okay, Linux separate session will be there. Just these are the simple ones. You don't need to use command line. You can use your GUI also for this, but just to get familiarized with the command line, that's always better. Okay, these are the commands. Status command, add command, commit. Then you have log commands. See, whatever commands I have used in the class, I'll be placing in the drive. You can use them with your recording. Class recording will be shared. Okay. Go through the class recording, go through these commands and do the hands-on. Okay, hands-on, please try to do the hands-on, whatever we discussed. As it's just a day one of our hands-on, this is enough for today. Okay, tomorrow on we'll get into the advanced concepts. These are the basics like deleting the files, branching, merging, rebase, pull with the rebase, reset. Yeah, lot many things are coming up. Stash, so many things are there in the Git. You can also check the course content. Tomorrow we shall get into those concepts. So that is all for today. Any questions here from anyone, please let me know. Any questions regarding a notes or a lab or anything you have?
Preeti, maybe I missed it. So you were trying to modify the file in the GUI, right? And
Yeah.
you found that you were not able to see the changes, but
Yeah.
is it because you did not commit it?
Yeah, actually it is not saved. See here, I didn't save it. I thought when I close it will be saved, but it is not. You have to save it.
Oh, okay.
Do you want to reload it using the loss changes? Okay, you have to save it explicitly. Okay, now you see.
Got it. Okay. But when you open it, the changes are there, but
Yeah, means it was not saved. When I open it, it was there, but it is not saved properly.
okay.
See, just it is a notepad plus plus, right? Just use a text pad like just normal notepad and try it. It should be working both the ways. Actually, what we'll do is today, because it's a day when I just use simple notepad and all. The real practice in real time, we'll use some editors like this Visual Studio Code. Okay, it's very simple, just an editor. On the day one itself, I don't want to put all of them. We'll use an editor like this. I'll open my Git folder here. Open the folder. This is some Kubernetes files. So our folder we can open like this. We have to install this Visual Studio Code. Just it's a simple editor kind of. Okay, just come here. See, here you see the files. Also go to terminal. You can open your Git bash here because Notepad++ sometimes changes may not be saved properly, and also don't use GUI in real time. Okay, this is how we use. You open the files here, edit here, save here, see here. Okay, save it, Control S, save it. Now here you see the status. Git bash can be launched here. You just work this way on the same interface rather than opening Git bash here, then Notepad, whether it is saved or not. Instead of all this hassle, this is how we use in reality. Many of the
Okay.
projects are looking for this Visual Studio Code experience also. Means you should be familiarized with this interface. All the projects are using this a lot. So I'll also introduce this. It will be better handy for you. Tomorrow we shall use this. Yes, Kalyani, sure, I'll share you the yesterday's class recording also. Yes, I'll do that. Please leave your email IDs, not in this chart. Put your email ID in my WhatsApp. On my personal WhatsApp window, please put your email IDs. Okay, I'll share them to the email. Got it, Sushmita? How to
Yeah, I
install
got it.
this?
Mhm.
This editor link is also there in the drive. You can install it and use this. This is very handy and this is the better approach.
You're going to send me the link for the drive?
Yes, I'll share the complete drive with all the commands, everything. Okay. Share your email IDs on the WhatsApp. Okay, my WhatsApp number is 1 second. Um, I don't remember my number. Yeah, here is my number. Can you please note down, Kalyani? Here is my number. Okay. So tomorrow onwards, like it's a regular class. 2 days, it's like a demo. So to continue, please confirm and get registered. And see you all tomorrow. Any more questions? You can reach me on WhatsApp, or else you can call. Okay. All right then. Bye everyone.
Thank you.
Yeah. See you all. Have a great day.
You too. Bye.